Hi and welcome to another episode of Ordinary Differential Equations. This is going to be the last lecture on interval of existence. So we are going to do problem that we mentioned 2 lectures ago, and we are going to bring it to a conclusion today. I hope you have done it already and you find out that your solution is correct. So let's go ahead and see what is the problem. So this is a problem we mentioned a while back. Y prime is equal to t squared over y times 1 plus t cubed, and y at time 0 is given as some y sub 0. We want to find the interval of existence as a function of y0. Well, once again, you remember that we had this issue one of the early lectures. We looked at our denominator and make sure we are not dividing by 0 and such. So of course I cannot have y equal to 0, so but that's not going to tell me what the interval of existence is. And then this is at t equal to minus 1, also this one becomes 0. So obviously we have to stay away from that. Since our t is at the starting point is 0, that definitely means that we have to stay above minus 1. But that does not make it clear as to what the interval of existence is. It's rather complicated. If you go ahead and take a look at d field, let's see what does d field tell us. So that's my equation. I wrote t squared over y times 1 plus t cubed, and I do graphing of the phase plane. And here are some solutions that I've already clicked on. So almost y0 is 1, and here is 1.5, and is almost 3. You notice that I don't go past minus 1 definitely, so all these solutions are going all the way to plus infinity. But the question is, where do they start at? Like for example, when I click at this point, I don't go back as minus 1. I'm stopping short of that. If I come closer, you see that I am even stopping earlier. So if I come here, here's another example. You see that they have a hook at the beginning of them, and that is what makes the problem a little bit interesting and a bit more complicated than others. Let's go ahead and see how we are going to handle that. By the way, when you see this stop sign coming up, it means the program, the software also had an issue. That's when it hits the end of interval of existence, it kind of gets bogged down. He doesn't know, the software doesn't know what to do either. And then you have to help him by stopping him and saying, okay, don't work on it anymore. There is nothing for you to do. So if you go somewhere else and click, the software doesn't respond to you because it's still trying to figure out what's going on here. So it isn't just an issue for us, but even for the software to run properly, and we need to guide it around this kind of difficult points. So here, if you press stop here, then you go somewhere, and then you can run another run of these things. So every now and then the software has an issue, and then you need to help it by stopping and restarting. Okay, let's go ahead. Solving this itself is not a big task. We're just gonna separate. So I have dy dt is equal to t squared over 1 plus t cubed. I cross multiply, so I have y dy. Some people would take an issue saying that I cross multiply, but let's take it with a grain of salt and move on with. So what we do now is that we integrate both sides, so that is rather quick. I'll have y squared over 2 And let me see, is everybody up to speed as to how to do this integral on the right hand side? It's a standard problem in Calculus 1, and you should be quick in answering that. So perhaps one of the places, if you haven't investigated this problem, is to think about how to handle that problem. What is the integral on the right hand side? Okay, let's see. Well, of course, you make a u substitution, 1 plus t cubed. So of course du is 3t squared dt, and so dt times t squared is going to be du over 3. So when I do the substitution, this becomes du over 3, and then this is just u. So obviously I have 1/3 of logarithm of absolute value of u plus a constant. Well, now let's go replace our substitution. So I have y squared over 2 is equal to 1/3 of logarithm of absolute value of 1 plus t cubed, and then our constant. Well, how do we handle the constant? We said when t is 0, y has to be y0. But when t is 0, 1 plus t cubed is just 1. Logarithm of 1 is 0. So this expression falls out, and I have y squared over 2 is equal to the constant of this problem. So fortunately, excuse me, y squared over 2 is equal to 1/3 of logarithm of 1 plus t cubed plus y0 squared over 2. I cross multiply. So y squared is 2/3 of logarithm of 1 plus t cubed plus y0 squared. Now, next step is can we simplify this thing and get rid of the absolute value sign? Well, so long as 1 plus t cubed is positive, that's same as the absolute value of 1 plus t cubed. Well, is it positive or negative? Could I go, for example, if t was minus 2, this becomes minus 7, and of course that's not positive. So how do we simplify? We use our initial condition. Say around t equal to 0, this is positive. So when I start, this is positive. Well, what if I move backward until it becomes 0? Well, once it becomes 0, the whole process is going to stop. That would be, if we do get there, that would be in end of interval of existence. So subject to the assumption that 1 plus t cubed is going to stay positive, this problem is going to turn out to be 2/3 of logarithm of 1 plus t cubed plus y0 squared. Now what is y? Well, y is going to be plus or minus this thing. Well, which one? Is it plus or is it minus? There is one solution. You cannot say there are two solutions, pick whatever you want. No, it's not what you want. There is one solution. Well, which one is it? Well, if y0 is positive at t equal to 0, this becomes 0, and square root of that has to match y0. So if y0 is positive, I have to pick a plus, and if y0 is negative, I have to pick minus. So the solution is splits like this. You pick the positive sign if at the beginning you want to go through a positive point. So this is the solution that applies if y0 were positive. What if y0 were negative? So that would be, now you employ the negative. This is a subtle point. I hope that you go back and try to convince yourself again. Well, okay, we have the solution. How do we get the interval of existence out of it? Where is my interval of existence? This is just the solution of ODE. So again, this is the major point for you to uh, rely on yourself and carry this to the conclusion. What should I do to get my interval of existence? Okay, give yourself 10-15 minutes and try to resolve that and then bring it back. Well, the issue is that if I have a radical, then my radicand has to be positive. That is what the limitation is. So 2/3 of logarithm of 1 plus t cubed plus y0 has to be, y0 squared has to be positive. That is what is limiting your solution. Well, the question is, what is t equal to or larger than? Okay, so that 10 or 15 minutes that I was giving you was for careful solution of that inequality and telling me what the answer would be. So let's go ahead. It's not actually that bad. It's a standard problem from your pre-calculus. So I rearrange this because I'm trying to focus on t. So I'm going to try to extract my t. So I'll have logarithm of 1 plus t cubed. Let me keep my 2/3 here. Larger than minus y0 squared. Next, I cross multiply. So logarithm of 1 plus t cubed is larger than what? Minus 3/2 of y0 squared. Then what? I still want to extract t. Well, you have to remove layers one at a time. You start from the most exterior layer and remove that and move inward. So how do I get rid of my logarithm? If I have a logarithm here, how do I get rid of it? I'm sure you know. So this is again a place for you to always try to do it yourself. So I exponentiate. So exponentiate 1 plus t cubed has to be larger than exponential of minus 3/2 of y0 squared. Well, you can take the 1 to the other side. So t cubed becomes exponential of minus 3/2 of y0 squared minus 1. Notice exponential of a negative exponent will be a number less than 1. So when you do a subtraction, this number here is going to be a negative number. So I take a cube root. Exponential of minus 3/2 of y0 squared minus 1. T has to be larger than that. So for example, if you want y0 to be 1, you calculate the exponential of minus 3/2, subtract 1, something, take cube root of it, and that is where the t is going to start. That's the meaning of this little hook on this picture that we have. So let me erase everything so that we are okay, suppose y0 is equal to 1. y0 equal to 1 would be here. I know most of the solution is going to be pointing to the right side, but there's a little hook on the left, and the question is how far back does it go? So here, well, again, I forgot this. By the way, down here you see the coordinates you are at, so that tells you if you're really close or not. I'm trying to be at 1, but it's not quite 1, so but let's go ahead and draw it anyway. Okay, so I almost clicked at 1, y0 was equal to 1. You see that it starts to back up to this location. It's close to -1, but it's not quite -1. To see the difference, come closer to 0, and then you see, yes. So starting at this point, I can go as far back as this, and that's the start of the interval of existence. On the right side, I have no issue. I can go as far to the right as I want, but I'm limited at this point. Sulfur has a problem too. You have to stop it. If you want to try another point, here let's try a negative y0. You see almost the same thing. Okay, so this is going to be the last lecture on interval of existence. We looked at it several different ways, and the story is a major difference between linear and nonlinear equations on this issue. There are also other issues on that distinguishes between linear and nonlinear. I'll invite you to read more about it from your textbook, but we are going to move on to more newer topics for ourselves. So we are going to move on to chapter 3. Okay, until next lecture, good luck and God bless.